Hi guys, this is video tutorial for NeutrinoParticles editor, and in this tutorial I will show you how to use multi-distributions for emitter guide values. To save time I will use a sample which I made in previous tutorial in graphs shift. You can see the same blinking stars. Let me remind you how it's done. In transparency section, I use over particle time graph, which describes blinking pattern. This graph is looped to the right, and there is shift used for this graph. So x-axis of it is randomly shift for each particle from 0 to 2 seconds. You can see bursts of particles by 20 particles, and each particle blinks independently because of this shift. So, and now about multi-distributions. For example, I also want to fade particles in and out during their lives. I can't make that with only one graph, like over particle time or over particle life, because I have blinking pattern with random shift. And obviously I also need to use over particle life simultaneously with this blinking graph. In this case I need to use multi-distribution for this transparency value. You can see M button here, make multi-distribution. When you press it, the value is transformed from single distribution to multi-distributions. I also add another one distribution and make it over particle life. Then for this over particle life graph I make desired fade in and fade out graph, and in the end I need to multiply my blinking to this graph. You can see blinking is A value and this fade in fade out over particle life is B value. So in expression field I type A multiplied by B, and you can see all particles blink and fade in and fade out simultaneously. So with this multi-distribution you can specify several different distributions, independent distributions, and combine them with custom expression. In this expression you can use all four mathematical operations: multiply, divide, division, plus, minus, and also several different functions. You will find a link to descriptions to this expression description with a list of that functions in description of this video. Now let me back to this multi-value, multi-distribution, and let's overview additional controls you have for this multi-distribution. You can add new distribution with this button. When you edit some variable, name will be assigned to the distribution like C, and you can multiply or divide by C and use this C in any other way in the expression. You can also remove distribution, remove row. As you can see, expression became invalid because we don't have C anymore. I fix it. Also, you can change dimensions of distributions. You can see each of these two distributions has dimensions 1, so this is only one-dimensional value. You can switch it to two-dimensional or three-dimensional. But of course you need to consider that in the expression because result of this expression should be only one-dimensional for transparency or three-dimensional for color. So you will need to somehow transform that three-dimensional value to the one-dimensional value to the one-dimensional for transparency. You can also use constant inside expression like multiply by 0.5 and all transparency will be half semi-transparent. And if you want to get back to the single distribution from multi-distribution, you need to delete all unnecessary rows to left on, you need to left only one row and then switch press this make single distribution button and you will have single distribution again. In the multi-distribution you can have only one distribution, only one row, only one variable, and you can use it in the expression like multiplying or dividing or somehow else. And another one example with color. I'm going to show you how to interpolate, to make linear interpolation between two specified colors during particle's life. You can do that with a single color graph over particle life. But just to show you how multi-distribution work, I'm going to do that with several different distributions. So for color, I make multi-distribution. This will be white color. Add another one distribution, transform it to three-dimensional, and it will be red color. And the third distribution will be one-dimensional over particle life graph. I will make it just from 0 to 1. And the expression will look like this, and it will be linear interpolation. You can see that vectors or three-dimensional values are subtracted and multiplied. So when a three-dimensional value is subtracted from another three-dimensional value, each component of first value is subtracted from each component of the second value, and the result of this subtraction is three-dimensional vector. When single value is multiplied by a vector, each component of that vector is multiplied by a single value, and the result will be three-dimensional vector or three-dimensional value. And then three-dimensional vector is added to another one, three-dimensional vector, and the result will be three-dimensional vector. In our case, this will be color. Later you will probably have a single function to make this kind of interpolation between two values. So it will be much simpler to make such interpolation in expression. So this is it for multi-distribution, and enjoy a new level of flexibility. Thank you. See you.